Good day guys and gals, it's me Paul and welcome to our video. Today we will discuss about how to solve the volume and the area of a spherical segment. But before we go on to that, we will tackle first about sphere. So now let us define the definition of a spherical segment. The spherical segment is a solid bounded by two parallel lines through a sphere. A sphere is a three-dimensional round-shaped object. Unlike other three-dimensional shapes, a sphere does not have any vertices or edges. All the points on the surface of the sphere are equidistant from its center. In other words, the distance from the center of the sphere to any point on the surface of the sphere is equal. There are many real-world objects that we see around us which are spherical in shape. Like this ball, it is a spherical in shape. Our planet Earth is not in a perfect shape of a sphere, but it is called a spheroid. The reason it is called a spheroid is that it is almost similar to that of a sphere. So, guys and gals, we all know what is the definition of a sphere. So we will go on to the volume and area of a spherical segment. So these are the properties of a spherical segment. First is the base, or in plural, bases. Bases of a spherical segment are the sections made by the parallel lines. The radii of the lower and upper sections are denoted by A and B respectively. If one of the parallel planes is tangent to the sphere, the solid thus formed is a spherical segment of one base. The spherical segment of one base is also called spherical cap, and the two bases is also called the spherical frustum. The altitude of the spherical segment is the perpendicular distance between the bases. It is denoted by letter H. Before we proceed, we would like to thank the sponsor for this video, Santon Plus Herbal Capsule. It is made from Garcinia Mangustana Santon, locally known as mangosteen. The first white flash offers a unique blend of sweet and tangy tastes, while the hard purple skin were originally boiled in water to treat diarrhea. So don't forget to buy Santon Plus Herbal Capsule in your nearest drugstore. So here are the formula to solve for the area and volume of the sphere. But first, we will talk about the formula for the area of a spherical segment. A is equals to pi times the quantity A squared plus B squared plus 2 times R times H. So here are the formulas to solve for the volume of a spherical segment. Take note that there are two different formulas to solve for the volume of the sphere, depending on the number of its base. So for the spherical segment of two bases, or the spherical frustum, here is the formula. V is equals to 1 over 6 times pi times h times the quantity 3a squared plus 3b squared plus h squared. The volume of a spherical segment of one base, or a spherical cap, here it is the formula. V is equals to 1/3 times pi times h squared times the quantity 3r minus h. So here it is how we solve the area of a spherical segment. Here it is the formula of the spherical segment. Here is the sample problem, which states that a spherical segment have a lower base of 30 centimeters upper base of 60 centimeters, height of 20 centimeters, the radius of the sphere, which is 90 centimeters. So as we all know, all the variable on our formula, so we simply substitute it. So here it is, A is equals to pi, which is equals to 3.14 times 30 centimeter squared plus 60 centimeters squared plus 2 times 90 centimeters times 20 centimeters. A is equals to 3.14, 30 times 30 equals to 900 centimeters squared, 60 times 60 is equals to 3,600 centimeters squared, plus 2 times 90 times 20 is equals to 3,600 centimeters squared. So we will go on. A is equals to 3.14, 900 times 3,600 is equals to 4,500 centimeters squared, plus 3,600, which is 8,100 centimeters squared, times 3.14. Therefore, our area is equals to 25,434 square centimeters. So we are still on the sample problem number 1, but in this case we will about to find the volume of a spherical segment with 2 bases. So here it is, the formula of the volume. Here it is, the substitution we performed. V is equals to 1 over 6 pi, which is equal to 3.14, height, which is equal to 20 centimeter. The lower base, or the letter A, is equals to 30 centimeters. B is equals to 60 centimeters, and of course our height is equals to 20 centimeters also. So 1 over 6 times 3.14 times 20 is 10.46 times 3 times 900 plus 3 times 3,600 plus 400. So we go on, 10.46 times the quantity 2,700 plus 10,800 plus 400. So here it is, the value for the next step. Volume is equals to 10.46 times 13,900 centimeters. So here it is, our final value of the volume is equals to 145,394 cubic centimeters. So we move on how to find the volume of a spherical segment, but in this case it is only with 1 base, which means that the spherical segment is a spherical cap. So here is the formula to find the volume. Here is the sample problem, which states that the spherical segment with only 1 base, given the radius of 6 centimeters, height of 12 centimeters. So with this given formula, we just substitute all the variables. V is equals to 1/3 times 14 with a height of 12 centimeters squared times the quantity 3 times 6 centimeters minus 12 centimeters. So we go on. Volume is equals to 1/3 times 3.14. 12 times 12 is equals to 144 centimeters squared. 3 times 6 is equals to 18 centimeters minus 12 centimeters. So 1/3 times 3.14 times 144 centimeters squared is equals to 150.72 centimeters squared times 6 centimeters. So 150.72 centimeters squared times 6 centimeters is equals to 904.32 cubic centimeters. Guys and gals, that ends our video for today. Don't forget to review always, because by failing to prepare, you are preparing to fail. Thank you for watching. Stay safe and God bless.